as Mark mentioned, I'm going to talk about the services that we offer now through PATH from the CHTCondor team, from the Open Science Grid team, and other partners we work with for advancing campus research by working with campuses on developing high throughput computing and high throughput computing facilitation capacity on their own campuses. And part of why I have a picture of myself on this first slide is to remind me to introduce myself. I lead research computing facilitation at the University of Wisconsin-Madison in the Center for High Throughput Computing, and also for the Open Science Grid. And because of that, I'm also a co-PI on the PATH project, leading facilitation services and co-leading community empowerment. So the services that I'd like to talk to you about today, one are the services that CHTCondor itself provides to help you build local HTC capacity. And then that we also provide in supporting your researchers to use high throughput computing or even the Open Science Grid today. So I'll talk about how you can send researchers to use CHTCondor or can practice using CHTCondor yourself if you're at a US research institution of some sort. And then I'll go into a little bit more depth into one aspect of supporting your researchers to use HTC, which is high throughput computing facilitation training that we offer, where I'll talk a little bit about the history of facilitation and how you can learn from our facilitators at UW-Madison. And then the last thing I'll touch on is how to share local resources via OSG as yet another way to integrate your campus research plan into a distributed high throughput computing framework in the Open Science Grid. All of these services are free and open to campuses with facilitation just for campuses. And if you'd like to discuss any of them, plans for your own campus to support high throughput computing as part of your whole research computing plan, please just send us an email and I'll repeat that particular email address, support@opensciencegrid.org, a couple of other times. And as you heard from Roan yesterday, part of why we're formalizing all of these services together and communicating them as one set is the result of our new funding in the partnership to Advance Throughput Computing, which is a partnership between CHTC, where CHTCondor is developed and where we support researchers locally at UW-Madison, along with other things we do, and that partnership with the Open Science Grid, or OSG. So let's first talk about building local HTC capacity. Maybe you didn't know this, but for various organizations, including campuses, the CHTCondor team provides personalized consulting on your campus HTC plan. So talking sort of big picture, including how you facilitate researchers, how this fits into research computing and data services available to your researchers, both locally and beyond your campus, including specific consulting on CHTCondor implementation and system configuration. There are a number of organizations that already meet sort of regularly with CHTCondor staff in order to support their own research communities. And this also gives you access to all other CHTC experts, including our systems administrators of CHTCondor systems, our facilitators, et cetera. And in case you didn't already know, especially for those who are newer to CHTCondor Week, there are a number of ways to engage with the broader CHTCondor community and the CHTCondor team. You can get in touch directly with the CHTCondor team. There's community-based support in the HTCondor users list, and then meetings like these are yet another way to engage. And you'll hear just a little bit later this morning from George Washington University about their local HTC plan and how they've been working with the CHTCondor team through various mechanisms on this slide. And if you're still maybe steps away from building local HTC capacity on your campus, you can still support your researchers to use OSG now. And I'd first like to talk about the service called OSG Connect, which is for researchers who don't otherwise have an access point designated for them to access the Open Science Grid. And the Open Science Grid really is a distributed high throughput computing environment. That's also a place where people could, become or be introduced to CHTCondor, job submission, and our facilitation practices. So anybody at a US affiliated or US academic government or nonprofit institution or a collaborator of a project based at one of these can use the OSG Connect service. This is an OSG supported access point that comes with an obligated initial consultation with one of our research computing facilitators, online documentation and examples, support for software, and lots of data space, as you might expect from a nationally supported computing service. And you'll actually get to hear from a user of OSG Connect, Nick Cooley, later today, so be on the lookout for his talk too. And for those of you who may not know what the OSG is, I mentioned it's a distributed high throughput computing environment, and it's really a consortium or a partnership in itself of researchers and institutions who share their computing and data resources through the distributed high throughput computing technologies that we develop in Condor and in the Open Science Grid, or OSG. And all of this is in support of open science. Who participates? Researchers themselves, of course, as our primary user base. There are multi-institutional collaborations, both with researchers and with resources that are pooled together through the OSG. Science gateways represent sort of another group of use case that can benefit from the capacity in OSG. And then, of course, the academic institutions and national laboratories that support all of the above are usually the entities that are operating in some way the infrastructure that is brought together in the OSG. So campuses are critical to OSG's ability to advance research, and our story here about high throughput computing services for campuses. And one of the ways that I describe OSG to people is that it's a computing environment with multiple virtual pools or virtual clusters, each of which can be made of capacity from a variety and number of distributed sites, like campuses and national labs who have computing clusters that they'd like to share or contribute. And while a number of national laboratories and some institutions have their own pools listed to the right of this graph, the OSG, or Open Science Pool, is the OSG operated pool that we intend for campuses to be able to have their own access points to submit to. I'll mention that a bit later. And that otherwise small multi-institutional collaborations and individual research groups can access, including access through OSG Connect, which is the set of access points that we operate for researchers who don't have their own associated with their campus or their research project. And the Open Science Pool, as is the case for high throughput computing broadly, really supports well a wide range of research domains. You can see our breakdown in this data to the left across different research domains, where the life sciences really play a significant part in the usage of these resources. But we support really the broad spectrum of research domains in the Open Science Pool because high throughput computing is applicable to them. And then there are a large number of institutions for whom these projects come from. More than 95 campuses with projects that have used the Open Science Pool itself in the last year. And there are others that, of course, might have or get to use pools associated with campuses or other projects. But in the Open Science Pool, 25 or more of these projects are from campuses with recent CC Star Awards. I'll talk about the Campus Cyber Infrastructure program in NSF a little bit later in this presentation. And more than 35 of these projects are from non-R1 institutions. You can see some of those even in this list of the top 20 at right. So Marone's point yesterday is very much true. You don't have to be at a well-resourced institution or have a significant computing background to benefit from the Open Science Pool as a researcher. And I mentioned that campuses can have their own access point into the Open Science Pool. So as part of your high throughput computing strategy, at any point you can pursue operating your own access point that submits into the Open Science Pool. And it's kind of like having a cluster, the Open Science Pool, where you don't have to administer all the worker nodes, but you can still own the user experience. This means that the institution gets to decide how it supports local users while still relying on OSG's general user documentation, software support tools, et cetera. But the institution gets to decide user authentication and authorization, perhaps to give local users an experience using their own institutional identity, and also integrating any local storage that they're already using. So this means that they don't have to bring their data to the OSG Connect access points if you have your own. And you do some Condor administration on the submit node, but of course OSG supports you there as well to make sure things are configured and working well. And you do not have to share resources into the Open Science Pool to have an access point. These are completely independent services. And I'll describe resource sharing a little bit later. And while we don't have anybody at Condor Week talking about the service, the OSG All Hands meeting included a presentation from the American Museum of Natural History, which is engaging with OSG on multiple fronts, but they spoke specifically about the benefits and process of supporting their own access point into OSG. And because Condor is at the heart of the coordination that access points provide to users, users can submit from an access point and perhaps access capacity on a local cluster, even if it's not Condor. We can help you set that up. By submitting to the Open Science Pool, OSG's meta-scheduling service automatically provides access to the Open Science Pool's group of contributed clusters from across different institutions. And because Condor is at the heart of this, it can be configured through the Open Science Pool to allow a researcher to access an allocation on a national supercomputing resource like those attributed or affiliated with Exceed, and can even bring in and procure commercial cloud resources on behalf of the user using Condor's native features for doing so. And in fact, if your access point is tied to a local Condor system, you can control all of those features, allowing for your researchers to use allocations and cloud resources from your own Condor pool instead of needing OSG to do that support. So those are sort of the access-specific components of supporting your researchers to use high throughput computing today, if they qualify for using OSG Connect, or if you otherwise have local resources that you've built up that they can use. But I want to talk a little bit about another component of support, which is HTC Facilitation training, in part because we have a tremendous amount of expertise at UW-Madison and CHTC that campuses can leverage too. And we formalized this in sort of two different sets of learning opportunities. One is HTC Facilitation shadowing, in which you can join OSG's facilitators in facilitating the use of OSG Connect by researchers from your own institution. So as you point researchers to use OSG Connect, and we meet with them like we do all new users of that service, you are welcome to have that researcher include you on any email communications. You're welcome to show up to that meeting, and you're welcome over time to be more and more involved in facilitating users, perhaps on the way to having your own access point. Additionally, we offer intensive shadowing at UW-Madison. So before the pandemic, we've had a number of campuses send people to just spend a week with us, observing how we support our local researchers on our high throughput computing system, which is the largest computing system we have on campus, as well as other types of computing as well. And I'll talk about those in just a second. Then we also offer formalized HTC facilitation training now. This is included both in parts of our DHTC campus workshop series that I'll highlight again at the end of this presentation, and in external presentations and trainings that are oriented for research computing facilitators on how to use OSG and high throughput computing systems, but more importantly, how to support researchers who need to do so. So we've got one of those coming up at PERC 21. We just did one at Rocky Mountain Advanced Computing Consortium last week, and we're improving and sort of bringing this opportunity to learn facilitation to more venues. But one of the reasons why you might actually care to come to UW-Madison and or to shadow our OSG facilitators is that the title Research Computing Facilitator originated at UW-Madison. And we've published a paper on our particular principles and philosophy around this, which are really geared toward proactive relationship building and partnership with researchers, teaching researchers to fish through computing, meaning that, using the old adage that if you hand somebody a fish, you feed them for a day, but if you teach them to fish, you feed them for life. We want to teach our researchers through this proactive relationship how they can best take advantage of the computing resources available to them, and so that they can foresee future opportunities and greater possibilities in their research through computing. And then we do, of course, a lot of advocacy into our own organizations and various stakeholders that fund the computing resources we support, as well as being able to liaise collaborations between researchers, since we meet with so many of them. So just to give you a picture of our computing environment on campus, we've really got a campus grid of different Condor pools. CHTC's is the largest. And a researcher submitting from one of our local access points or submit nodes in Condor language through Condor File Transfer can flag their jobs to run not just in the CHTC pool, but in other pools on campus, out to the cloud using Condor's features, and out to the open science grid where our campus happens to have its own pool. And an individual researcher can regularly obtain in excess of 100,000 CPU hours per day this way. We also provide a dedicated cluster for MPI only work, but that cluster, though it looks like a traditional HPC cluster, is a lot smaller, and it's backfilled as part of our CHTC pool. So it's actually included in here. And when we first implemented this approach to research computing facilitators with my hire in 2013, we were just becoming the campus computing center, even though we've been providing computing resources and developing Condor technologies for decades, as you probably know. But after hiring a couple of facilitators, including myself and Christina Cook, who you'll hear from next, we had significant increase in uptake by the life sciences and social sciences in particular. And more importantly, because we were meeting with researchers and pointing them to the right resources and the right way to run computing for their work, we were able to quantify that nearly all of the usage from those particular research domains really benefited most from high throughput computing, and researchers were running it in a high throughput computing way on our resources. Furthermore, researchers even from domains that have traditionally driven developments in high performance computing, most of their work has been on our high throughput computing system as well. Consistent with what we've heard from the future directions for the NSF ACI from the National Academies of Sciences, which is linked here. So like Marone mentioned, high throughput computing really democratizes access to computing resources. Condor makes it very easy to submit lots of computing tasks that otherwise look a lot like what somebody might run on their own laptop. And the high throughput computing approach applies to a very wide range of different research methodologies that are truly represented across all the research domains that we support on our large and diverse campus. This includes text analysis, parameter sweeps, and other types of model optimization or optimization approaches with many what can be independent sort of simulations or calculations. Similar, anything that's doing multiple simulations that are relatively smaller versus focusing on a singular large high resolution simulation is a good high throughput computing use case. And image and video analysis or other multiple sample analyses. We see these a lot in the life sciences, even outside of genomics. These are all really good use cases for high throughput computing. And this impact from our facilitators and our support and focus on high throughput computing has played out over the years since then, just to demonstrate how much high touch we are with our facilitation approaches. We've performed over 500 research consultations in the last year with more than 300 unique office hours visits, supporting the 320 different research groups. And I believe we delivered 360 million compute hours in the last year to these groups who are almost exclusively on our campus. And you can actually hear research examples from people in this community on Thursday of Condor Week. So be on the lookout for that. If you're really interested in how we do research computing facilitation, I wanted to add and echo what Mark mentioned, which is that we're currently hiring. In fact, the deadline to apply is May 31st to join our research computing facilitation team, where you'll contribute to facilitation of researchers both at UW-Madison using CHTC and using OSG via OSG Connect. So see more information on that page. So just jumping back, these are the various ways that you can learn HTC facilitation from us. Make sure to check those out if you are thinking about enhancing what you provide to researchers on your campus to include dedicated high throughput computing resources of some sort. And one other thing I wanted to add is that the OSG User School in 2021, which is virtual, the deadline for that is this Friday. So we've been blasting emails to various community lists of research computing professionals and partners. But if you haven't gotten any of those, please feel free to bug us or me specifically, and we can help you get an advertising email out to your research community ASAP. We hope to resume the on-site experience of the OSG User School in 2022. But this is a great opportunity for both researchers and anybody who supports research computing to learn high throughput computing principles and how to use the OSG specifically. So the last couple of services I want to talk about are relevant to sharing resources into the open science grid. So even if your campus is really not yet ready to jump in and pursue any of these other services, if you've got a local cluster, you can already contribute to and be part of a high throughput computing community by sharing resources into the open science grid. And when pursuing this, like hundreds or over 100 campuses have done with the open science pool, you decide which research communities you share with. The open science pool, of course, is our most diverse research community, but there are pools for other research communities that I mentioned, specific to different multi-institutional collaborations or institutions. And you or OSG operate a component called a compute entry point that submits pilot jobs into your cluster, and then those pilots running OSG software bring in OSG user jobs. But you get to control how that works on your local cluster, even if we operate the compute entry point, and then we provide data on the research projects that you've impacted through OSG. 55 campuses in the last year, the top 20 are at the right, contributed to the open science pool specifically, though there are many more that contribute across OSG. And at least 15 of those are from 2019 or 2020 Campus Cyber Infrastructure Awards. And that number is growing daily as we add more and more of those institutions while they are funding local computing with CC Star awards that requires a component of resource sharing into or to the broader community. And if you haven't heard about the Campus Cyber Infrastructure Program, this is NSF's category of several different funding opportunities to plan and then build up local research computing capabilities, including things like networking, funding clusters. And if you fund a cluster, like I mentioned, there's a requirement to share resources more broadly, with OSG mentioned as one of the ways to do this. But we can provide consulting for any CC Star proposal, and really even kind of beyond what I mentioned so far in this presentation in terms of developing the science drivers, and then of course OSG integration and other high throughput computing integration into your research computing plan. We've provided more than 60 support letters since 2019, and you can get in touch with us at this address. And I just wanted to highlight, as we're rounding up to the end, there are a lot of secondary benefits to engaging with the Condor and OSG communities beyond advancing research computing capabilities for your own researchers. For example, by engaging with what is an international CI ecosystem, you can learn from OSG and CI staff at a number of institutions and countries, identify collaboration opportunities, and there's significant funding advantages to doing so. For example, institutions that first shared resources into OSG before pursuing a CC Star Compute Award have all been funded. I'm highlighting on this page, so I won't go into detail, a lot of other opportunities to learn more with events operated by Condor and OSG, as well as other forms of training materials that you can find. And I'll take questions as you look at these email addresses to get in touch to talk about any of these services.